Ever wondered how to make your Angular app truly dynamic by seamlessly integrating live data from an API? The key to unlocking this potential lies in mastering data binding, and today we are diving deep into making it happen. Hello and welcome back to our channel where we transform coding challenges into everyday solutions. I am Ayaz Zafar, and if you have been around the Angular blog, you know how powerful it can be in bringing data-driven web application to life. But if you are new here, you might be asking, how do I get my Angular app to not just display data but to interact with it in real time? With over 12 years of experience as an Angular developer, I have tackled projects ranging from enterprise-level applications to innovative startups. One project that sounds out involved integrating complex APIs to provide live updates for a financial dashboard, showcasing the real power of Angular in action. Today, we are not just talking about the theory behind data binding in Angular, we are diving into the practical side, showing you step by step how to bind data in Angular using APIs. Whether you are fetching user data, displaying real-time stock prices, or anything in between, understanding how to effectively bind API data is crucial for modern web app development. We will cover the basics of data binding, including interpolation, property binding, event binding, and the much-loved two-way binding. Then we will move on to the making API calls with Angular HTTP client, transforming raw data into engaging UI elements, and even delve into advanced techniques for real-time data handling. Whether you are here to brush up on your skills or starting from scratch, you are in the right place. So grab a cup of coffee, fire up your code editor, and let's get started on this journey to unlocking the full potential of your Angular applications with API data binding. At the heart of Angular application lies a power concept known as data binding. It's the bridge between TypeScript code and the HTML view, allowing for interactive and dynamic web applications. Let's break it down. Data binding in Angular can be categorized into four main types: interpolation, property binding, event binding, and two-way binding. Each plays a unique role in how data flows from your application to view and back. Starting with interpolation, which you might recognize as double curly braces. This is Angular's way of displaying component data in HTML template. It's one way from the component to the view. Here, the message is property in your component that gets displayed in a paragraph tag in your HTML. Simple yet incredibly powerful for displaying dynamic data. Next, we have property binding, used to set properties of HTML elements. The syntax source image URL binds property values from the component to the HTML. In this example, image URL from your component dynamically sets the source of an image element. Event binding allows your app to respond to user actions in browser. By binding HTML events, you can execute component methods in response. Here, clicking the button calls the handle click method in your component. Lastly, two-way data binding is combination of property and event binding, allowing for real-time synchronization between component and the view. This example demonstrates how user input is kept in sync between the input field and the component property, perfect for forms and interactive elements. Understanding these data bindings techniques is crucial, especially when integrating APIs. They allow your Angular app to display and interact with dynamic data seamlessly. Now that we have laid the groundwork with data binding, let's get our hands dirty by setting up an Angular component. First, ensure you have Node.js installed. Then install the Angular CLI globally using npm nodes package manager. Let me show you my Node.js version. I have version 18.16.0. Now run the command npm install -g at angular/CLI. Angular CLI is installed. Next, we will create a new Angular project with this CLI. So for that, run the command ng new project name. Press enter and follow the prompts to set up your project. For this tutorial, you can skip the routing and choose the CSS or SAS or SCSS for styling. I already have generated the project and I will be using that. Let me start the server ngserve-o that will open the app in the browser. To make API calls, we need to add HTTP client module to our app. If you are still using app modules and you're not using the standalone component, then you need to import the HTTP client module in your app module. But if you are using the latest version of Angular 17 like I am, and I'm using standalone component, in that case you don't need to do that. You simply go to the app.config and you need to add this function in the providers array, provide HTTP client. If you pass the response of this function call, then the HTTP client service would be available throughout the entire application that you will be able to use in any part of your application. By importing the HTTP client module or by providing the HTTP client, we unlock the ability to inject HTTP client into our components, paving the way for API integration. With our Angular project set up and ready to go, we are now equipped to fetch and bind data from APIs, bringing dynamic content to our users. Now that our Angular environment is set up, it's time to bring it to life with data from an API. Using Angular's HTTP client, we can easily fetch data from any RESTful API. First things first, let's understand the HTTP client. It's a powerful library provided by Angular for making HTTP requests. Today we will focus on GET request, which is most commonly used to retrieve data. To use HTTP client, we first need to inject it in our component. You can use your constructor, but I will be using the inject function. That is the latest way to inject any service in your component. This gives us access to its methods, including the get method for fetching data. So let's do that. I'm going to my component, that is app component, and here I will define a variable or property, private HTTP is equal to inject. Make sure to import the inject function from angular/core and pass the service that you want to inject. I want to inject the HTTP client. Now I will define a property, a function, fetch data. I will use this .http.get. Here I will be using the JSON placeholder, that is a fake API that gives you fake data, but it is actual API that is online available, free to use. So I am getting the users and I will subscribe to the get method, get function, and now here I will console the data, and now I will create a constructor so that I could call my this.fetchData function. So here we are injecting HTTP client into our component. In the fetch data method, we use http.get to request data from an example API, and we subscribe to the observable it returns to handle the data once it is received. When we call this.http.get, Angular sends a GET request to the specified URL. The subscribe method then listens for the response and allowing us to process the data as soon as it is available. Let's put this into action. We will fetch a list of items from a public API and log the result to the console. So open the inspect element in the browser. Let me reload it again and expand this array. And this is a list of users that is coming from here. And there you have it, live data fetched directly from an API and displayed right in our console. This is just the beginning of what's possible. Fetching data is just one part of the question. Next, let's bind this data to our components, transforming it into a visual elements our users can interact with. To display our fetched data, we will store it in a component property and use Angular's data binding to reflect it in HTML template. So let's define a property here, items any array, and by default I will give it an empty array, and this time instead of showing it in console, I will save it in the items variable. Now items will hold the data fetched from the API. We have updated the type to any array on the line number 15 to reflect that it is an array of items we are expecting. Further, you can specify that what kind of data you are getting by using the generic types. So here you can pass any array. Okay, so with that you don't have to specify as any here. You can just get rid of that, because if you don't do that and you also remove the generic type from here, then you may get error like this, the type mismatch error. So for that we have to add the type in the generic. With our data in place, let's bind it to our HTML using interpolation for displaying text and property binding for attributes. So here I will first add the UL tag, and then I will add the li tag, and then I will add the image tag. Okay, now let's reformat it a little bit. Now I will wrap the list tag in the for loop. Here I will add item of items, track by track item, and this. Okay, paste it here. Now here I will add item.name. Okay, and in the image we will show the image item.url. I don't know what is the property name for the image. Let me quickly display the JSON in the HTML by using JSON pipe. So right now in this dataset there is no image URL, so I will just skip that image tag, but we will keep using the other information. You can now remove it. Okay, so now you can see that this data is coming from the API. Here we are using for to iterate over each item in our items array. We display the item's name using interpolation. Now let me also add our tooltip here by using the title attribute, and here I will pass the value item.name. So whenever a user hover on it, they will see the name in the tooltip as well. So this is a default tooltip or title that you can add. We have binded the item.name with the list elements title attribute using property binding. And now the moment of truth. Let's see our app in action, dynamically displaying data fetched from the API. As you can see, the data we fetched is now beautifully rendered in our application, and title is also being shown on hover. This is power of Angular's data binding in action, seamlessly integrating API data into our app. You have just taken a crucial step towards creating dynamic and data-driven application. Fetching and binding data from APIs might seem daunting at first, but as we have seen today, Angular makes it intuitive and straightforward. Having mastered the basics of data binding and API integration, let's explore more advanced techniques that can elevate your Angular applications to new heights. A common feature in dynamic applications is our real-time data updates. Angular's observables and the async pipes offer a streamlined approach to handle asynchronous data streams like those from APIs, especially useful for features like live search. Observables are at the core of Angular's asynchronous programming model that allow you to work with multiple values over time, and the async pipe lets you subscribe to an observable directly from the template, simplifying your code. Let's implement a search feature that filters our API data in real time as user types. We will use form control from Angular's reactive forms module to capture the input and filter out the data list. So in order to use form control, we have to import the reactive forms module in our component. So if you are using standalone component, then you can directly import the reactive forms module in here in the imports array. But if you are still using the non-standalone components and you are declaring your component in a specific in some module, then you should import the reactive forms module in that module where your component is declared. Alright, now let's define a component property with the name search control is equal to new form control, filtered items is equal to this dot search control dot value changes dot pipe. Okay, and now we will pass some operators. Debounce time, make sure to import the debounce time from the RxJS and pass the time 300 milliseconds, and then distinct until changed. Make sure to import this function as well, and then we will pass the operator switch map. This will expect a callback function that will also receive a parameter search term, and we will return this dot filter items function and pass it the search term. So we have to define this function filter item. So let's define this function filter items, and it will receive search term string, and then I will return this dot http dot get any, and this time I am passing the query in the API request, so it will return user based on the query. Okay, so let me quickly explain. This value changes is an observable that emits whenever the input value changes. We use the debounce time to wait until typing has stopped for 300 milliseconds, and distinct until changed to ignore repeated values, and switch map to call our filtering logic with the latest search term. This approach is not only provides a seamless user experience but also optimizes our API usage by reducing unnecessary calls. Now let me quickly show you the benefit of this approach. So let's bind this search control with an input. So go to the HTML. Here I will add an input. Okay, now let's add an input. So here I have added the type text and form control. Here I have passed the control directly to it, and I gave it a placeholder search. Now let's see in the browser. So this is what we have currently. Let me open the inspect element to observe the network request as well. Here let me select the XHR. Now we have to make another change. Instead of using items array directly, I will use the filtered items here. Okay, so I have used the async here, and this time I don't need the fetch data function here. Let's remove as well. Okay, now you can see that whenever you type something in the input, it sends a request to the API. So let's try that. I typed A and it sent a request to the API with the query A. If you type B, then it will send request with that character. Let me type some more specific term, GLENNA. Okay, so I will show you the benefit of using these approaches. Like we have used the debounce time and distinct until change. So first of all, I will quickly type multiple characters and it will just send request after 300 milliseconds. It will not detect change before that. So for example, ABC, it sent one request for the ABC, not for A, B and C. It did not send the 3 requests. It sent only one request. So if you don't add this one here, if you don't include the debounce time, then if you type ABC really quick, then it will send 3 requests. So as many number, it will send as many requests as many number of characters in your string. So for example, ABC, you can see it sent 3 requests. So that's not a good thing. So to fix that, we added a debounce time. You can also increase the debounce time as well depending on your needs. So for example, hello, it sent request after very long time, after 1 second. Okay, fetching data from an API is not always smooth sailing. Handling errors gracefully is essential for a robust Angular application. Let's add error handling to our data fetching method using RxJS catch error operator. So we can intercept errors and provide feedback to the users. So let's say you have a function fetch data like before, and this will use this. But before subscribing to it, you will use the pipe function on it. And here you will use catch error operator that should be imported from the RxJS library, and pass it a callback function like this. Okay, now you can use this error message to console it in the logs, and then you will return an array of observable. Make sure to import the of function from RxJS. So now if the API call fails, we log the error and ensure our application continues running smoothly by returning a default value. Optimizing API calls is crucial for performance. Using RxJS operators like debounce time and distinct until changed, which we saw in our search feature, minimizes the frequency of calls and enhancing efficiency. These operations help prevent our app from making too many API requests, saving bandwidth and improving user experience by only fetching data when truly needed. Error handling and optimization are key to developing professional-grade Angular applications. By implementing these practices, you ensure your app is both resilient and efficient, ready to handle real-world challenges. And there you have it, a comprehensive journey through the essentials of binding data in Angular applications using APIs. We have covered everything from the basics of data binding, setting up your Angular environment, fetching data from APIs, to advanced techniques and best practices for error handling and optimizing API calls. We started with an understanding of Angular's data binding concepts, including interpolation, property binding, event binding, and two-way binding. We then walked through setting up an Angular project and using HTTP client to fetch data from APIs. Not stopping there, we dove into binding this data to components and creating dynamic and interactive user interfaces. But we did not stop at the basics. We explored advanced techniques like using observables and the async pipe for real-time data updates and implemented a live search feature. Finally, we discussed the importance of error handling and optimizing API calls to ensure our applications are both robust and efficient. Now it's your turn to take these concepts and apply them to your projects. Experiment with different APIs, play around with data binding, and see what applications you can build. If you have found this tutorial helpful, don't forget to hit that subscribe button and turn on notifications. We've got plenty more Angular tutorials and development tips to help you on your coding journey. Thank you so much for watching how to bind data in Angular using API. Your support means the world to us. So like, comment, and share if you enjoyed this tutorial. For more in-depth guides and resources, be sure to visit our blog or website linked in description below. Until next time, happy coding.